Alright, so I'm back. And where we last left off was getting the is now figuring out the designated ports for each segment, and based off of that, figuring out who's going to be blocking and who's going to be the forwarding port. So we'll take it segment by segment. So our first segment, we'll focus on the segment between switch 6 and switch 2. Right? So let's go back to our rules. So the one with the lowest cost to the root is going to be the one who gets the designated forwarding port. What's his cost? 56. What's his cost? 100 to the root, right? So his cost to the root is much greater than this cost. So because he has the lower cost, he is going to get the designated port, right? And he's going to get the alternating port. The alternate port. And this link will be blocked. There's our first segment. Right, same thing here. Switch 2 to switch 5. So we figure out who has the lowest cost to the bridge. His cost is 100 to the root bridge. His cost is 100. We have a tie. So what's next? The lowest bridge ID. And that's going to be the combination of the priority and the MAC address. And who has the lowest? We can compare the MAC addresses. We see that's switch 2. So in this case, switch 2 will get the designated port, right? Give me that. And switch 5 will get the alternate. And he's blocking. Perfect. So, starting from there again, looking at this segment, between switch 2 and switch 3, we notice that switch 2, we figure out what the root cost is. His is 100, his is 156, right? So he obviously has the lowest. He's going to get the designated port, and he will get the alternate. And that link is blocked, right? You're seeing how this all works out, and eventually, we'll start jumping in the next segment. So switch 3. We look at the two uplinks between switch 5 and switch 1, and then the uplink between switch 5 and switch 1, those two interfaces, right? So which one has the lowest cost to the root bridge? His cost is 156, so his is 156. His cost is 100, so who's going to get the designated port role? Switch 5, correct. Because switch 5 has the lowest cost to the root bridge. And that's going to happen in both links, right? So what we're going to end up here with is two alternate links on switch 3 with both of those interfaces completely blocking. Perfect. So now let's look at the segment between switch 3 and switch 4. The cost to the root bridge is 200 for switch 3. The cost for switch 4 is 156. So who gets the designated port here? Switch 4. And this becomes redundant. Like I said, once you start figuring this out in sections, all you just go by link that hasn't gone through the port selection, and it's pretty easy to figure out, who gets designated and who gets the alternate. That link is blocked, right? So same thing here. We're going to look at these two uplinks now. So that's his root port. So we want to look at the uplink between switch 4 and switch 6. His cost to get to the root bridge is going to be 156, right? Switch 6's cost to get to the root bridge is 56. So who gets the designated port on the segment? Switch 6. And switch 4 gets the alternate. And that will be blocked. Perfect. Now switch 4 to switch 5. Same thing. His cost is 156 to get to the root. His cost is 100. So he's going to get the designated port as well. And he will get the alternate. And that link is blocked. Now, if we start tracing out all the links, everything should go through, everything should be filtering, going through this switch 1. So essentially, how switch 2 gets the switch 1 is through its root port. I feel like something is missing here. No. Oh, gotta have another designated port, that's why. go. Alright, so switch 6 goes to switch 1 through its root port, right? Now, switch 3 goes through switch 6 to get to switch 1, right? Switch 4, same thing, goes through switch 6 to get to switch 1. And switch 5 goes through switch, it goes directly to switch 1 going through its root port. See, now you see the loop-free topology. And you also see a lot of insufficient switching because who's going to get the load? This guy here. You know, by design, what we wanted to do was configure these two switches to become the root of the domain and essentially put the workload on these two for any kind of TCM plugs, right? Now, let's hit the lab and we can kind of confirm what we're seeing here. And you know, let's go to the GNS3 topology. So this is the GNS3 topology that you're seeing. It's pretty much the same exact layout. And we're just going to verify what we see here based off of our calculations. And we should hopefully be okay. If not, we'll figure out why. That's the whole point of learning. You get to troubleshoot. So, you know, if we may have made an incorrect guess on the port, we'll figure out why and, you know, we'll work from there. So, let's log into switch 1 and we're going to focus on VLAN 1 in this case. So spanning tree VLAN 1. Now, exactly what we thought. We have the root is this bridge here. Oh, okay, and that was one of the things that I saw that I didn't do. Which it doesn't really make a huge difference, but I didn't enable rapid spanning tree. It's also good practice, that or configure multiple spanning tree, which is still rapid spanning tree, but right now this is still the old 802.1d, regular slow spanning tree. So, you know, but for this example, we don't really need rapid spanning tree for what we're going to be doing. So, back to the network here. Now, we do a show CDP neighbor. Show CDP neighbors. Cool. So, Ethernet 02 is facing switch 5, right? And we can see, you know, all the designated ports. That's my port channel. Switch 5 is Ethernet 02. And then Ethernet 03 is facing switch 2, right? And we see all those ports are designated, as we should see. Perfect. Now, let's jump to switch 2 and see what switch 2 is doing. So, show spanning tree VLAN 1. Perfect. Now, we see some root ports, we see some designated, and we see alternate blocking, and then we see a designated. Perfecto. So, I think that's pretty much what we're seeing here. So, let's do a show CDP neighbor, right? So Ethernet, so let's look at the blocking port first. Ethernet 01 is the port facing switch 6. Is he blocking? Correct, he is alternate because switch 6 has the better root cost to the root bridge. So he's going to be blocking. Now, our root port is going to be the port facing switch 1, right? Which is going to be, our root port is Ethernet 02. Now, Ethernet 02 is the one facing switch 1, as it should be, right? Now, we have two designated ports, one going towards switch 5, which is Ethernet, which is actually going to be our port channel 1, which is a forwarding state, right? And then we have the other connection to switch 3, which is going to be our Ethernet 03, which is in a forwarding state, right? Perfecto. Now let's hop over to switch 3. Same thing. We should see the link between switch 3 and 6, the root port, and everything else on this switch should actually be blocking. So, show span tree VLAN 1. Perfect. And show CDP neighbor. And exactly what we confirmed. We have the 3 blocking ports and 1 forwarding going towards that uplink towards switch 6. And as we see here, that's exactly correct, right? We have blocking ports, we have our blocking ports, and then the uplink to switch 6. Perfecto. Now, let's go ahead and hop over to switch 4. And let's try to see the same thing. Show span. Now, before we hit that command, our root port should be one of the ports facing switch 6. I don't know which one because I didn't label the ports, but Either way, this is going to represent one of those 2 ports. So spanning tree VLAN 1, show CDP neighbor. Perfecto. So we have 2 switch interfaces going towards them. Switch 6 has O1, which is forwarding. Well, okay, so why is 5 being blocked on O2? Okay, no, it's supposed to be blocked. Okay, cool. I'm tripping out. So my root port is going to be forwarding. Did I do a port channel on switch 4? Oh, you know what? I did not mean to do a port channel on switch 4. So, well, let's unbuild that because that's definitely not what I wanted. Show IP interface brief. Yeah, so that makes sense. I'm like, what the heck? So, Ethernet 0, 0, Ethernet range. Ah, it sucks. Config interface range ETX 0, 0 through 1. Okay, so we got 0, 0 through 1. We're gonna do a no channel group of 1. And that was going to switch 6, I believe. So we want to go so CDP neighbor range Ethernet 1/0 Ethernet 0 0/3 channel group, and that should bring down 0 0/3. Perfect. Now show CDP, show spanning tree VLAN 1. Now it looks a little bit better. That's what I was wondering. Like, we should see some more blocking ports there. Now we got our blocking ports. Perfecto. So our root port is going to be show CDP neighbor. Now, our root port is switch 5, as it should be. One of the ports, like I said, that's facing... Whoa. It must not be done. Okay, now I'm tripping out. Okay. Man, I hate when I do that. So, our root port is Ethernet 00, and Ethernet 00 is, like I said, one of those 2 ports facing switch 6. But remember, I told you, it's going to be the lowest advertised port going towards switch 6. So, his remote port going to Ethernet 01 for switch 6 is going to be reported port of 10, right? His going to be 30. And actually, you can see what the port ID is by doing a show span interface Ethernet 0/1, and you can see the port priority number, right? So his is 128.2. We can look at that same thing for switch 6. So let's go to switch 6, show span interface 3 03, and then the other port was 10, right? Now, the one with the lowest port priority is this 128.4. So because the advertised port priority that switch 4 received is 128.4, which should be correlating, the interface that's correlating with that, this is going to be interface 03. The interface correlating with that with which one, 03 is the Ethernet 00 interface, which became the root port. So now you see how that happened, because we have essentially 2 uplinks to the same switch with equal cost. The tying factor in that case was the lowest port ID, which we proved that the port ID coming from this interface was the lowest, so this is why this port is the root port. And then we look at all our blocking ports, the Ethernet 01 and 02, which is on the other links to switch 5 and switch 6. You can see we're blocking and we're alternate blocking. And Ethernet 03, which is this connection. know what? I got those two. 56. 156. Alright, so it's a good thing that I seen that. No. I think we, see, this is the beauty of it. Alright, so we're going to go to part 3. The video's getting a little long, so chop this down. We'll start again. Alright.